So transition metal questions do have a huge amount of factual recall. There's lots of things to learn and remember and be able to restate. Taking a look at this first one here, the type of bond between the oxygen and the hydrogen within this compound. There's many different types of bonding that exists within ligands. We look at covalent, coordinate, we've also got ionic here. But within the water ligand, the OH bond is covalent. So that's what we're looking for on the first question. Now we also look at something that might not be hugely familiar. You don't get many questions where you have a complex that looks like the one at the top here, CuH2O6, Cl2. Normally you would see it as CuH2O6 plus 2. So when you think about it in that way, that tells you that we're actually looking at an ionic compound here. We're looking at the chloride ions being bonded to the copper complex. So for that reason, they're not ligands, they're not forming the coordinate bonds. Now when we move on and we start to look at specific reactions that take place here, excess of ammonia added to a sample, and you've got to write down what the equation is. Now to do this, you've got to remember that in the specific circumstance of hexa-aqua copper 2 ions and adding ammonia, only 4 of the ligands are replaced. So this is the equation that you would have to put down. And again, remembering the facts, you would have to know that that gives us a deep blue solution. In terms of the 7.4, aqueous sodium carbonate added to another sample of solution A to form a blue-green solid C. Again, it's knowing this web of reactions, knowing the product, knowing the observations, and recognising that this is copper carbonate. Moving on to 7.5, we've got reagent D added to another sample of solution A, this time a yellow-green solution. We want to know what that reagent D is, and we need an ionic equation, and it's important that we read through the question carefully to make sure that we're giving the ionic equation and nothing else. So the reagent here is HCl, and the reaction that we get is, as we can see here, we've got the chloride ions replacing the water ligand. So we end up with our new chloro complex. Now there's a few things to consider here. In first instance, you've got to remember that because the chloro ligands have a -1 charge, that affects the overall charge on the complex. So my +2 has become -2 because of the 4 -1s. It's also really important that you're remembering that chloro ligands, you can only fit 4 of them around the central metal ion. So it does give a tetrahedral rather than an octahedral complex. Okay, finally, when we look at the question about colorimetry, we've got CuCl2-, and it's asking why we couldn't use colorimetry in this case. Well, it's actually hinging on the idea that we're dealing with a copper plus ion, and you would need to work that out. You'd need to realise that your CuCl2-, the 2- from the chlorine, leaves copper as +1. And I've written out the electron configuration here for a copper plus ion, and we can see that it's lost its 4s1, but it remains as 3d10. Now, because it doesn't have a partially filled D sublevel, it's not transitional, and you can't get the DD transitions that we get that lead to coloured compounds. So the bit in black is what we're really focusing on here, that it won't form coloured compounds, so it cannot be colorimetry that's used to determine the concentration of it.